Okay, I think I'm going to type because it'll be neater if I do that. Easier to read. So we're going to use everything that we learned to figure out how to write the Verilog for this Mealy type circuit. So we're told it's a Mealy type circuit. It has a 2-bit output, S, and S has S1, S0, except we'll do it just as a 2-bit number. And state A is the reset state. So you'll start, as you start all Verilogs, with module. And give it a name, and I will call it question 2. Then we're going to put our inputs and outputs. So we have the clock, and then reset in, which I use because that's what all my examples have. So I like to, copy from my examples. So when we're looking at our state table here, and we look under the outputs, we see that we have separate columns for R equals 0 and R equals 1. That is your giveaway that this is a Mealy machine. Because if it was a Moore machine, you wouldn't have separate columns because it doesn't depend on the input. Oh. So, like if we go back and look at question 1 here, this was a Moore machine. And when we look at our output, we don't have separate columns for t equals 0 and t equals 1.
Right. And it just confused me because, because we had both U and V. Instead, because you can't
Right.
just have 1 or 2 or so
Right,
on. So
right. And in this one, we're going to have 2, but we're going to treat them as 1 because we're going to treat them together as a 2-bit number. So, yeah, it can be tricky. But the main thing is that you look at the entire column, and do you have a column that one of them is dependent on the value, if the value of the input being 0 and 1, or the value of the input being 1. And just so you know, you don't have to just have inputs being 0 or 1. You can have inputs being 0, 1, 2, 3. So your inputs can be more as well. So, okay, so we have the clock, and we have reset in, and we have R is our input, and S, I made it a capital S, is my output. Okay, so now we'll say which ones are our inputs. Our inputs are clock, reset in, and R, semicolon. And our output is reg, because we're changing it in the always block. We're changing it in the always block because it's a Mealy machine. 1, 0, because it's a 2-bit number. S, semicolon. So that's our output. So S is made up of S0 and S1, and there they are right there. The S1, S0. I'm just treating them together as one number, capital S. Okay, now I'm going to define my parameters so that I don't have to put in 0, 0, 0, 1, and all that every time. I just have 3 states, so I only need 2 flip-flops, or 2 bits. So parameter 1, 0, because I just need the 2 bits. And I'll have A equals 2, that's saying it's binary. Or no, 2, sorry, 2, it's 2 bits long. B is binary, and 0, 0. B equals 2, B 0, 1. Now I don't have to do this. Notice my state table, nowhere in my directions did it say what A, B, and C had to be. I could make them whatever I wanted to, and if I wanted to have them be 4 bits, I could. And C equals to be 1, 0. You could make it 1, 1 if you wanted.
Why does it not matter? Like, I thought it would because first off, you need the correct number of flip flops, right?
Yes. I would just be wasteful.
That could just be 0, 0.
Right. It would just be wasteful.
Right, and then does it not matter what your assignment was?
No, because these are just placeholders. I'm not doing any math with them at all.
Okay, right.
So the reset end, it's just there in case of emergency.
No, I mean sometimes you need to reset your machine back to a starting position.
Okay.
So
That's what I mean by
yeah.
emergencies, when it just gets over clouded.
Well, if you are doing a demonstration for a project,
Okay.
then and you are told to do these inputs and you do those inputs, it's like, okay, well, let's now start over. You reset and you start over, because in the meantime, not just your outputs have changed, but all your states have changed. So, okay, and then also we have our current state and next state, and those are reg as well because we are also changing those in the always block. Current state and next state. Okay, now we have our first always block. So our first always block we use to define our next states. And so this is going to happen. So this is always at. And we do this whenever our current state changes. Our current state changes when we do that next always block at the bottom at the edge of the clock or at the reset, or when the input changes. So if the input changes, it recalculates the states. It doesn't change the states, though. It doesn't change the states until you get to the positive edge of the clock. So always at y, comma, r. So always at one of these, if one of these changes, then you're going to recalculate the states. Okay, so now we want to look at a case statement. And this is going to say, okay, well, let's look at what state we're in right now. What state are we in? And once we look at that, we're going to figure out what we're going to do next. Okay, so first, let's say we're in state A. So if we're in state A, our next state is going to be C, no matter what. So I'm just going to go ahead and do that without putting it inside the if. So I'm going to say y equals C, semicolon. But my output is different depending on whether my input is 0 or my input is 1. So I can say if R of course I'm doing this differently than I did on my sheet here. I do not want that. Okay, if R, then S equals 1, 0. Else S equals and forgetting my semicolons. And not only that, notice I have two statements here. I have y equals c, that's one statement, and then I have an if. So all that whole if there, that's if and then one thing and else and then one thing, that's all one thing. So that's one thing, and then the y equals c is another thing, but that's still two things, so I need to have a begin.
I have a question.
Yes.
Is Verilog finicky about the way you do spacing?
No.
Okay.
It's been over a year since I actually programmed something and had to check it for bugs, and I'm familiar with a number of different languages, and I get confused a lot as to which ones do what. I'm pretty sure the answer to your question is no, because I think if it was yes, I would remember and say yes, and it drives me crazy. So I would think. Okay, so all right. Now let's take a look at if we're in state B. So now things are different if R is 0 and R is 1 as to what the next state is. So I can say if R then now I have to have a begin here because I'm going to have two lines here because I have to say both what the next state is and what the output is. So and y equals C, S equals 1, 0, and else begin. So now I'm in state B and R is 0, y equals A, S equals 1, 1. Now notice I didn't have a begin and end on my B case because for B there's only one thing, an if.
Yeah.
But within each if I have within the if and the else I have to have a begin and an end, but I don't need to have a begin and an end on the case for B itself. Extra begins and ends don't hurt anything. Okay, now C if R let's see. So R was 1. The next state is B. And the output is 0, 1. And if R is 0, the output is, I got that backwards, right? If R was 1, the output was A. And if R is 0, the output is B. Not the output, next state. Next state. And the output for 0 is 0, 0. Probably could have written this by hand quicker, but then you couldn't read it, so there's that. Okay, so now we need to have the default. And we're going to set two things here. So y equals, now you can set it equal to something. I'm going to say it's y is 2-bit binary XX, that's a don't care. And that S is the same, also don't care. And then we're going to end our case statement. Now we need to have our next always block. And this always block is the one that defines the sequential block. And this one is always at negative edge reset in and positive edge of the clock. And if reset in, so I've seen it like this too, and this like really, that means the same thing. So if not reset in, I'm almost done. Okay. So if not reset in, or if reset in equals 0, then we'll let our default state be A. And I think we had to have that because, was that given? No, that was not given.
Yeah, it is.
Oh, it is given. Okay.
And state A is the reset state.
Okay, so we do have to have that. Okay, and then else, so if else, we're going to make our current state equal to the next state that we just calculated. And that is the end of our module. And that is the Verilog. Okay, so are there questions on that? Did it make a lot more sense after going through the examples of drawing the diagrams? Yeah.